Today we are going to discuss log normal distribution. Now log normal distribution is a continuous distribution, continuous random variable distribution. Now over here, why we are interested in log normal distribution? Because it is kind of used in accelerated life testing of electronic components. So electronic components, there is equation which is called Arrhenius equation, and which basically captures the effect of the temperature, and it is more suited for electronic components because electronic components are getting affected by temperature change. Higher temperature, the life of the electronic component reduces. That's the idea over here. That's the assumption over here. Now, like it has been found that there is a semiconductor material which is called gallium arsenide. Now, this gallium arsenide is typically used for making multiple electrical and electronic components like laser diodes, or something like optical windows, or maybe microwave frequency integrated circuits. So these are made by gallium arsenide. Now, it has been found over a period of time that gallium arsenide, the components made by gallium arsenide, they basically follow a distribution, and that distribution, the life of these components follows log normal probability distribution function. So what is log normal distribution? That we are discussing over here. So suppose T is the life over here, and T is the life made of these components which are made by gallium arsenide. And for these components we are discussing the life over here, and T is the life or time to failure. Typically life is nothing but time to failure. And for these we are writing this. So how can we write it? So for this we can say that T is going to follow, either you can write like this, and you write mu t comma sigma t square, or if you want to be more accurate, actually there is nothing, like it's only notation, so it doesn't make much change. Any of this you can write. Now what does it mean? So it means that when you are writing like this, it means that T follows log normal distribution with mean mu t and variance of sigma t square, and which, if we say that, it basically means that ln T is going to follow normal distribution, or I can write ln T is going to follow normal distribution with mean mu and variance sigma square over here. That is what it means. So now we are going to see like further into this, and we are going to basically derive certain things for log normal distribution, and that's what we are going to see over here now. So before I go ahead over here, I just want to clarify whatever I have written over here, and then we will basically start. So for clarifying, I have kind of made this picture in make this plot in MATLAB, but though I have regenerated in MATLAB, the basic idea has been taken from Wikipedia. So in Wikipedia, you can directly see that there is a plot which is basically something similar over here, and that's what we are also doing over here. That is the idea. So now let us see what is happening over here. So we have this log normal distribution which is over here. So this distribution over here which you are seeing over here, that is log normal distribution, and I have clicked over here. Now so that distribution, like I have taken the same variable as T over here, which is nothing but life, and that follows log normal distribution. We have not defined probability density function yet for log normal distribution. I am just showing you something else. So basically, if you see over here, there is an equation which is T is equal to e power y, and basically that is nothing but y is equal to ln of t, and the same thing is written over here. If you see, y is equal to ln of t. So as I mentioned that ln of t is going to follow normal distribution, and that's what you're seeing over here. So this is y, this is t over here, the variable, random variable is t over here, and the random variable over here is y, which is nothing but same as ln t, and this ln t follows normal distribution. Now normal distribution with mean mu and variance sigma square is plotted over here, and that's what you are seeing. And a very important point over here when we discuss log normal distribution is that ln x is norm. So basically the point over here which we are going to discuss is that basically ln x is monotonically increasing, because ln of t is monotonically increasing, and therefore there is a correspondence between this normal distribution and log normal distribution. So you can see that this point over here, which is mu over here, corresponding to this, I have taken some point over here. And see, for normal distribution, mean and median are same because it's a symmetric distribution. So So in other words, there is no skewness over here, and therefore mean and median are same. Mean, mode, and median, all three are same for normal distribution. However, that is not the case for log normal distribution. Log normal distribution, you can see that it is not symmetric anymore. It is a skewed distribution. To be more accurate, it is right skew distribution over here. So now at median, which is mu over here, because over here this area covered is 50% over here, and corresponding to this, because I already mentioned that LNT is monotonically increasing, and therefore if I take a point over here and take the corresponding point over here in T, so this is point in Y over here, and from this I am taking corresponding point in T. So the idea is, because LNT is monotonically increasing, and therefore the area covered over here will also be 50%, and that's why it is written over here as E of mu. I will derive it, and I will also derive this mean over here, which I have mentioned mu T over here, and that is how does it comes this particular value, that also I will derive. But the idea basically that LNT is monotonically increasing, that basically a little bit more seeps in when you see this particular picture, and that's why I have shown this particular picture over here. Now one more point which you can notice over here, that this E of T, because it is like basically over here it's not a symmetric distribution, and therefore E of T, that is mu of T, that is mean and median, they are different. So this area is 50%, and therefore the corresponding point over here is median. So E power mu is median, and this is mean over here. So that's what is the idea. Now let's go back and see how to basically derive these points. So as I mentioned, that most important point is that ln_t is basically monotonically increasing. So ln of t is monotonically increasing. So basically, because ln of t is now normally distributed. Now let me write it ln of t, where this capital T is basically a random variable. I have discussed this in my previous video also. So this is a notation which basically denotes the random variable, and t is one of the value. So like for example, this capital T can take many values, and one of such value is small t. That's the idea over here. So ln t is monotonically increasing, and therefore I can write something like this, and this I am writing about cumulative distribution function. Now cumulative distribution function, if you write, that is CDF, and that can be written as over here, that is P of, and that is ln of t, and that will be less than equal to ln of t. So how did I get this over here? So this I am directly, like I have already shown this earlier, that 50% and 50% is same for median. That's what I've shown, and therefore the area under the PDF is going to be same, and that is nothing but the CDF over here, and that's what I am just doing over here. So now this side I have not yet defined. So that is for log normal distribution, because I'm writing t over here. So that is for log normal distribution. I have not yet defined the function, but what is known to me is what is on right hand side, and that is for normal distribution. And for normal distribution I can write it like this. Yeah, so I in my over here, if you see whatever I have shown over here, in this what I have done, this is ln t over here. So this one is ln t over here, and it is normally distributed with mean mu and sigma over here, and for this is a plot over here. That is what we are writing over here, and we know that what is the, like, we are assuming over here that we know the PDF and CDF of normal distribution, and that we are going to use now. And so that is what I have done over here. So as you can as you can clearly see, what is mu over here. So mu is nothing but mean of, I'm writing it so that there is no confusion later on. So that's the or let me write it a little bit like in terms of this. So actually if I write, it is nothing but this. What is sigma? Sigma is nothing but standard deviation of ln_t. Let me write ln_t. So that is what is mu and sigma I have defined over here. Now like there is a parameter which is called Z statistic, like which probably more like you may be knowing, that it is basically defined as so in terms of, okay, let me let me just assume that what I have assumed earlier, that y is equal to ln t over here. So y is equal to ln t, and then I can write y minus mu divided by sigma. That is nothing but z, and that is called z statistic. And if I basically if I basically find CDF of this, then it is called standard normal distribution, because this z, the way z is defined, it is going to be normally distributed with 0 and 1, because the way it is defined over here, its mean will become 0. So what I'm doing over here, actually I'm okay, let me just show you over here. This I have discussed earlier also, but now I'm not defining it over here. So this is what I am doing over here, in case you are getting confused. So basically you have, you know, E of, so basically you can find E of z, and that you find from E of y minus mu by sigma. I don't want to tell the further steps. Follow this and you will find that z will be normally distributed with 0 and 1. How do you do for standard deviation? On the similar lines, but the corresponding formula I'm not writing over here. It's just for the hint over here. So now that is basically nothing but standard normal distribution. So how do you write that? So I can write it like this. So that is so basically f of okay, so this is nothing but over here, yeah. So that is what I have already written over here, and let me simply write it like 5, and then let me write it, because I have used a small t over here, and therefore I'm writing there. So now if I want to find out what is probability density function, so I can write for probability density function something like this. And what is this? This is nothing but d by dt, and that is of f of t. And what is f of t, which you can see over here? So f of t is already written over here, and that's what I'm going to do over here. So that is t of dt, and that is what I have written earlier also. So you can see I am copying the same step, whatever I have written over here, same thing I am copying over here. So once you do it like this, then you have to realize that it is basically standard normal distribution, I already mentioned earlier, and therefore I will get something like this, which is something like this. Now why I'm doing in terms of phi of z, so that is, there is a reason for that, because I know what is I know PDF of the normal distribution with mu and sigma, and that is the reason I'm doing it. Let me just put the value of ln t over here. So what will happen? So if I put the value of ln t, it will become ln t minus mu by sigma, and this will over here will become I made a mistake over here. I should write dt over here, and this will become d by dt into ln t minus mu divided by sigma. So now you can see I will have phi ln t minus mu divided by sigma divided by 1 by sigma. That is what I am going to get. Now over here I'm going to use directly, because I know what is the PDF of normal distribution. PDF of normal distribution I'm already aware of, and that is what I'm going to use. The PDF of normal distribution can be given as something like this. So I have written x over here, because I will replace it basically. So now in this if I put z is basically having, instead of x, if I replace by z, and z is normally distributed by 0 and 1. So basically in place of mu I have to put 0, in place of sigma I have to put 1, and I will get the same thing. That's the idea over here. So let me tell you then what I'm going to get is something like this. Phi z will become 1 by root. So again over here in place of sigma I have put 1 over here. So over here you have sigma, here I have put 1 over here, and then I will have e power minus half, and that is z square. That is what I am going to get over here. Now if I want if I want ln t minus mu by sigma over here, then I can write it as 1 by root 2 pi, and then I will have e power minus half, and then I can write whatever I had, ln t minus mu divided by sigma and whole square. Now I know that the relationship between like over here, whatever I have found over here, that is ft of t. Just see, so that is ft of t. Let me write over here so that we don't lose sight of it. And so I have already found this function. If I multiply this function by 1 by sigma t, I will find whatever I started for. So that's what I'm doing over here, and that is ft of t over here. And that you can see, if I write, then it will be t sigma root 2 pi, and then I can simply write e power minus uh, ln t minus mu whole square divided by 2 sigma square. That is what I'm going to get over here. So that is what is PDF of it. Now I have already found PDF of it. Now if I want to find the nth moment of it, see, if I want to find nth moment of whatever I have already found, then how do I find nth moment of it? So that is actually pretty simple. So I have done in previous videos also. So that is like, let's say let's say I want to find out like in general I'm writing, and then probably you can, anyway I have gotten t, so let me use t over here. So e of t power n, that is what I want to find out. So how do I find it? I will find it from 0 to infinity t power n, and then I will write ft of t into dt. That is what I have to do, and if I am able to do that, that is what I am going to find. So how do I find that? So I will write it. So that is t power n, and then I have whatever I have already found over here, that is divided by t sigma root 2 pi, and then I will write e power minus uh, ln t minus mu whole square divided by 2 sigma square. That is what I am going to write. Now one simple thing you can see over here, which I have already shown you in previous over here, like for example you can see I have written t is equal to e power y. Now same thing I am going to, the same change of variable I am going to do over here to get a easy expression over here. So let me write change of variables, and that is t is equal to e power y. So let me write over here so that I will get over here, I'm going to get so you see I'm not, like, you can write over here. So what will happen, dt will become dt is going to become e power y dy over here, and therefore when you're basically, your limits will are also going to change. So your limits are also going to change, and what is going to happen to your limits is this. So when your t tends to infinity, then your basically your y will become ln of t, and therefore y also will become infinity. And what will happen when your t tends to 0? So when your t tends to 0, your y will become minus infinity. So that is what is going to happen, and therefore you're going to have minus infinity plus infinity, and you will have e power y. And then because earlier we had this 1 t over here and 1 t over here, so I could have written this t from here, I can minus, and I can write minus 1 over here, and that is what I'm going to do now. So that is e power y whole power n minus 1 I have got. And then like dt I have over here, right? For example, okay, dt is over here, that dt I have already found as e power y, and then I will write dy over here, and this entire thing whatever you're seeing over here, that will become e power minus y minus mu divided by sigma whole square. And let me write like this is what I am going to have. So let me somehow I mix a lot of space over here, so let me write properly over here. So I'm going to get something like this: e power ny minus y over here, and then e power y over here, and then e power minus half, and then y minus mu divided by sigma whole square. And this is what I am going to have, and this over here I will have dy. So if you see, it is easy to see over here. You can and yeah, I have to divide it by this is over here, that is 1 by sigma root 2 pi, that is already there. So that is sigma root 2 pi. I have to divide it, that is keep on coming. So that is e power n by divide by sigma root 2 pi over here. And then after that, what is going to happen, then I'm going to have e power minus y minus mu whole square divided by 2 sigma square. That is what I'm going to have. Now it is very important to notice what you are getting over here. So this is a kind of so if you notice, like whatever I have written over here, what is that? See, earlier I have shown you know for normal distribution what is the PDF or probability density function. We started from there, so I will just take you to there and then you can try to compare. So that is okay, then we were somewhere over here. So yeah, so PDF of normal distribution. So here I have written in terms of x. So I could have written in terms of y or any other variable here itself, but typically because z is equal to normally x minus mu minus sigma, by sigma it is taken. So I wrote in terms of x. But if I replace simply x to y, if I replace this simply x to y, then you can come over here and you can see I have all the things, like whatever is there, everything is there. So what I have over here, that I can write as nothing as e of e power ny. That is what is I can write over here. So that is very important. Once you write like this e power ny over here, then you have to realize that this y, what is y over here? So y is ln of t, and this y has normal distribution. So y has normal distribution. Now what does it expression finally? So again, I'm writing something which I have covered in previous video. So I have defined a moment generating function for variable x and for random variable x. And how did I define it? I defined it like this. So you can see I defined it like this. You can see my previous videos and you will find it. So and this used to come, like I have done a separate video in it, and directly I'm taking result now. So this used to come something like this. So now if so over here basically what is happening, I have to find this, and over here x is normal distribution, over here y is normal distribution, over here instead of t I'm writing n. So whatever I have got over here, whatever this e power t e, so basically I am getting this e of t power n, and basically if I basically change t to n, and because mean are anyway same, so that is n mu and plus sigma square n square divided by 2. That is what I am going to get. So that is the idea over here. Now once I have got it, then what can I do after it? That we are going to see now. So we have to simply put the different value of n and we can find different things. For example, I can put n is equal to 1, then it will become e power t, and then n is equal to 1, this side is going to be e power mu plus sigma square by 2. Now this is mean of log normal distribution, because our t, now e of t we have found, and t is log normally distributed. So that is what I have found over here. Now see, this same thing we started with, this is there in my this figure over here. So you can see we started with the same expression over here, and now we have proved it. That's it. So what about variance of it? So it is very easy, as we have done multiple times till now. So now we can do e of t square over here. So if I find e of t square, so I have to, instead of n I have to put 2. So if I put 2 in place of n, then I will get e power 2 mu, and then I will get plus 2 sigma square. That's all. So now how do we find variance? So again, this step also I have done multiple times, not in this video but in previous video. And probably if you have a little bit knowledge of statistics now, like for example if you're not doing it for first time, then probably you are aware that what is happening over here. So let me write mu t over here, because earlier when I defined a log normal distribution, there I have written this as mu t over here. So that's what I am doing over here, mu t, t minus mu t, and then I will write over here, so that will be e of t square, and actually don't get confused because I have used small one over here, then that's what I'm going to use. So e of t and then whole square. So first term is e of 2 mu plus 2 sigma square, and the second term is E of mu plus sigma square by 2 and whole square. So that now you can simply see that it is 2 sigma square and then uh, minus E 2 mu plus sigma square. So if I take some common outside, so that is e power 2 mu plus sigma square. If I take it outside, I will have e power sigma square minus 1. So that is what you're seeing over here, and that is what is basically variance over here. That is what you have to see. Now how can I write basically in terms of mean over here? So you can realize that I found that it is nothing but E of t is nothing but this, and so what I have found over here, that is nothing but E of t I can write, and then the square of it, and then I can write E of square. So that is what is variance for this log normal distribution. So now in this particular video we have seen mean and variance of log normal distribution. Median I already defined earlier. How did I define median? Because that is how we started actually, because we are comparing the CDF of both the distribution. So we compared the CDF of both the distributions because we said that LNT will be monotonically increasing, and so we have found mean, median and variance. Other properties in the similar way you can find. So over here we'll stop today, and so basically we'll stop over here. Now for finding let before stopping I can actually give you proof. So maybe see, it's same thing I'm repeating another way. So basically now earlier what we said, that earlier when we started with this. So means it is nothing but I'm because whatever I showed in graph, same thing I'm writing in terms of in terms of expressions over here. That's all. So let me just show you. So that is ln t minus mu divided by sigma. Now what did we say? Like if I find at a particular point. So if so what is the definition of median? The definition of median is it is a time when the area basically the CDF is 0.5. The value of CDF is 0.5. So if I choose a area which is equal to e power mu, I'm just choosing one area, like one time instant, which is e power mu, and let's see what is the value of CDF on it. So that is e power mu. If I write over here, then that is nothing but I can write like this, and then it is ln of ln of e power mu will be mu minus mu divided by sigma. And you have to recall that right hand side whatever is there, that is nothing but normal distribution. So if you know the properties of normal distribution, you will see that it is coming 0, and for 0 like this 5 will become 0.5. So therefore the median of, it's a kind of small proof, therefore the median of log normal distribution is e power mu. That is what I can say over here. So that's the idea. So with this I will close this video, and in next video we will discuss what is Arrhenius equation,